Okay, thank you for coming out today. I hope I give you some information that makes sense, but a lot of this is kind of intuitive, and I hope it makes sense for you. So remember this kind of phrase: failing to plan is planning to fail. If you hope it doesn't rain, if you don't want to worry about the rain, 9 times out of 10, nature is going to hit you upside the head with a big baseball bat full of rain. So just some kind of things kind of drive home that point. Do it now, thank yourself later. Procrastination is like credit cards, a lot of fun until you get the bill. And the last one, a man who procrastinates in his choosing will inevitably have his choice made for him by circumstance. So if you don't plan for the weather will make that decision for you. These are some pictures of people who didn't think it was going to rain while they were out there doing their project. Well, of course it does. And they have control failures. They didn't think it would rain here. All across the country, we didn't think it would rain. In some instances, it can be pretty severe. We just installed our stormwater pipes, put them together, compacted them into the ground. Rained enough to cause them to separate and come back out. Now we're going to have some serious repairs. Basically, we get to do it again. Your stormwater pollution prevention plan is your best plan, your guide on how you're going to address this. Remember, a SWIP is meant for you to make changes on. It's designed for you to make changes. When somebody applied for the permit for your SWIP, they were guessing 3 months, 6 months, a year ago on what the weather would be. If they are accurate, let me have their name, because I'd like to make a lot of money on them predicting the weather. But they're usually not accurate. Ideally, everybody would like to do most of their work when it's not raining. It's easier. Nothing's going to wash off, right? But now we're seeing unpredictable weather patterns. I'm from Florida. We're getting 2-inch, 4-inch, 6-inch, 8 inches of rain in one thunderstorm. That's more than you get in a month here. It's a lot. You're getting the same amount of rain you get per year, but you're getting it all at once. That's only going to continue to happen. So you better plan on it raining. You should be able to survive what is a normal rainfall amount for your site. And I think I looked it up. A normal rainfall amount for Hawaii is, less than a 1/4 inch of rain. However, if you have tropical storms and things blowing around, that can go up 10 times, 100 times more than that, especially if it sits out there and just funnels rain in on top of you. But you all should be able to survive a normal rain event. When I was working at Disney and the Reedy Creek Improvement District, we couldn't do that initially back in the 80s. Sometimes we did, sometimes we didn't, but we had to learn to build things up. We had to learn that always on the low spot where the water flows, that's where we need most of our protection. You don't need it on top of the hill. You need it on the low spot. I don't need it necessarily next to where it might flow across a parking lot. I need it where it might flow into the wetlands or in the creek. That's what needs protection, or the water reservoir. Those are just things that make sense after a while. But a lot of people, when they design, they don't do that. They put a box around it, put compost, wattles or silt fence in Florida or whatever, and they're done. I'm like, you're not done. How can you tell if these things work? Go out when it's raining. Go out and look at it. Don't go out in the lightning. Go out when it's raining, have an umbrella, take pictures. See what works, see what does not work. If it doesn't work and it was installed properly, quit using it. Why are you using tools that don't work? We did that for a while. We used hay bales. They didn't work. They didn't work. They didn't work. Finally, we said, that's it. We'll get rid of them. It makes people think about something that does work. Layers of BMPs work. Layers of BMPs. Having perimeter controls, having things that slow down the flow, having things that can divert water. These all work. Can't get over there. You can see this on the hillside. They have their grass established. They have their channel beefed up before it goes down into the creek. Here they're trapping sediment as the flow's coming off of the road, going down into the beefed up channel. Same thing here. Here they beefed up the edge of the channel with some coconut. All these different things. And this didn't happen overnight. They didn't just go out there and do that. It took them a while to learn to do this. Understand the difference between sediment controls and erosion controls. We always call everything erosion control, but there is actually a difference. Sediment controls are measures we put in place while we're still pushing the soil around, while it can still flow off-site. They're the things we see a lot: the silt fences, the floating turbidity curtains, the inlet protection devices, and check dams. Those are sediment controls because water still has a chance to move the soil around. These cost you money and time. You have to maintain them. You have to clean the sediment out. This is where all your effort is. Go look at your inspections. Silt fence failed, wattle failed, check dam had to be cleaned out, inlet protection failed. That's where you're spending your time and your money. That's where you want to make changes. So how do you get to that? Well, as quick as you can, you want to go from sediment control to erosion control. Erosion control is our permanent stabilization, usually some type of vegetation or a rolled erosion control product. Hydroseeding, hydromulching, those are excellent tools. Even the riprap we put down, sometimes with the rolled erosion control products. We're done. You put that down right. Are you going to do any more maintenance on it? No, you're done. Unless something causes it to fail, you're done. So as fast as you can, you want to go from these controls to this control. Now, you can't do that overnight, but that means, how do you eat you may know what, this is kind of a silly question. How do you eat an elephant? One bite at a time, right? So how do you stabilize your site? One piece at a time. You get this graded, get your cover down. Get this graded, get your cover down. Don't wait till the whole thing's graded and then put your vegetation down. You're asking for trouble. If you get it graded in sequences and phases, when the water comes off, it's clean water and you won't have as much to deal with. It took me a long time to figure that out. I had to learn it the hard way. Had a lot of failure. I am a failure when it comes to BMPs. I have failed on many BMPs before I had success. How do you prepare? Let's say the forecast is for 3 or 4 days of rain. What can you do? What can you do to get ready in a short amount of time? Well, you can't go stabilize the whole site in 3 or 4 days. You're out there on it. So what are some things you can do? Well, again, in last-minute preparations, we want to know the accuracy of the weather forecast. Some weather forecasts, it's going to rain, and then nothing. Or it doesn't look like it's going to be much rain, and then the heavens open up. So get accurate weather. Walk on your site. See how does it look. Don't just look at the map, look at the SWIP. Actually go out there and see what it is. Most of the time there's a 5 to 7 day lag between what's actually happening on your site and what the documentation says. You have a week to get it caught up anyway. Know how water enters and leaves your site. That sounds basic as anything, but most people can't do that. Most people who are really good at designing CAD drawings couldn't go out to a site and tell you which way the water flows. Now, at the beginning, the water starts out in one direction. At the end, it may go the opposite. And while we're in between, it's going off in all directions because you're regrading subbasin A and subbasin B, and different parts are going to different areas. That's when it's difficult to figure out where the water's going. Reinforce any weaknesses in your fortress. If your controls are already run over by the equipment, or they're not installed right, or they look kind of flimsy, time to beef them up, right? A storm's coming. Beef it up. Have repair materials available. Silt fence doesn't go bad if it sits in your storage shed. You can use it on the next project. Some of these compost socks and other things, you should have extras for those. You should have extra repair materials on site so that they can fix it immediately. They can beef it up immediately. If it's not dangerous, have a repair crew available to go out in the weather and check on it. That's the call for management, but that's what keeps it. You don't want to wait till the whole site loses all their perimeter control. If you have a good crew that knows what they're doing, when it starts losing about as much as these small desks, they can get out there and fix it, or they can divert it. They can do something. We can look at all of our areas that we look at, our perimeters, our inlets. What are we doing for slope stabilization, stockpiles, flow channels, other things we can look at. We can add an extra row of that perimeter. Like I said, beef up the low spot. Add another row of your perimeter control. We can divert the water. We can put down our erosion blankets. Those are another thing to have on stock. Rolling those out real quick with a good crew, you can cover an area the size of this room in half an hour to an hour with a good crew. That can help. That can be critical. Mulch. In Florida, after we have hurricanes, we have trees down everywhere. Well, we grind it all up into mulch. There's free mulch. If it's not going to float, mulch protects that bare soil from that raindrop. It'll get you through that rain event. If you have some of that, that could be useful. And again, just some pictures to illustrate what I'm saying. There's a second row of silt fence. Here we've got our walls. There's some diversion channels. They've added a row of erosion control blankets to their perimeter. Here they're blowing mulch. If you use a hay mulch or something like that, you want to make sure that you crimp it in. If you just blow it out on the surface, the wind will blow it down to the low spot or the rain will wash it down. You have to go in and take like a disc, just run over it. It'll push it in about an inch or two. That makes a difference as well. Again, for our perimeters, just things we can do. We can interrupt the flow of water. We can stabilize upstream. Let's say if you know a hydromulch company, they can be your best friend just before the rain comes out. Maybe you've got a 50-acre site. They can't stabilize all of it. They can start at your perimeters and start giving you some extra protection right around that. Within an hour, you can have your site beefed up. After the rain event, you can get back and regrade it and do whatever you have to do, but it can get you through that. If you have jute from a landscape company, pieces of jute can help you in some instances. Again, there's our going on there. They installed, that's a coconut fiber matting with wattles there. Here's a hydromulch company coming in and stabilizing around the area. Again, these are real quick. I pick up the phone, call Joe or Steve, and he's out there in an hour getting it going. Inlets. Inlets are challenging. Inlets are where sometimes we can't do anything. There's so much flow coming through, or sometimes what we have doesn't work. Inlets has a lot more choices. When I started, your choice for inlet protection was rocks and silt fence. That was it. Now you have engineered solutions. Now you have type of wattle materials or mulch socks, things like that. Always make sure that the inlet has the ability to let the water overflow. If the inlet protection device sucks up to the curb, it will cause flooding. Even if you have that, you can fix that though. I'll show you that. You can add a little extra control around it, and again, too much water, send some of it in another direction. This is in Florida. A lot of times people like to use these drain field pipes. Let me see if I can get over here again. Problem with this is you'll see this goes right up in the curb inlet, and if you have a rain event, it will suction right up into it, and it'll cause flooding. So to fix that, what you can do is pull it out a little bit and put a sandbag in between it or half a concrete block that will allow overflow. This is geohay, artificial hay bale. This allows overflow coming into the inlet. This is a recycled tires in a geotextile called a gutter eel. But notice it has a pinched waist, so it allows overflow. This is a product called Silt Saver. It's a high-density polyethylene skeleton with a bag over it. It allows the water to flow through the sides, and it has an overflow port. Here somebody's used rock bags to allow water to get to the inlet and not go to their site. And here they've beefed it up with a little bit of jute around a silt fence inlet protection device. But again, don't have anything that suctions up to the inlet. That will cause flooding. This is good for overflow. That's good for overflow. You want overflow. If you can't get overflow, you'll have to pull your protections. It'll cause flooding. We can't have flooding, right? We can't have flooding. On slopes, we have different choices. We can protect the slope both temporarily and permanently with hydromulch. We can do our erosion blankets. RECPs is just the technical term for rolled erosion control products. You've seen erosion blankets. Jute again. And again, we can divert the water, get it flowing different directions. Again, I like hydromulch. Hydromulch instant. I used it one time to stabilize around a pond, very steep slope. An hour later, it rained 2 inches, and I thought, oh, there goes all my money washing into the lake, right? It didn't move. I was impressed. So once this is properly applied and gets out there, it'll survive quite a bit of rain and keep you from having to chase mud. You don't want to be chasing mud. That's a waste of your time. Not even counting any violations or rules or anything. You'll have to go get some more soil to put back on the slope. It's a waste of your time to go do that. Here's a good example of a rolled erosion control product. Protected, unprotected. You can see unprotected, we're down to gully erosion. That's all washing off. Somebody's going to have to bring that back up and regrade it. Here you can see some of the grass starting to grow up through the jute. That's a good thing. This is actually in Hawaii. I believe it was a project done recently along one of your highways. Here's a very steep slope with erosion blankets and wattles acting as check dams. Here's a diversion so that the water doesn't get a full run off the slope. Hopefully most of this is review. It's not anything new. You've seen this. It's just a matter of putting it together and making change, being willing to take a chance and make changes. Soil stockpiles. I saw some good examples in some of the pictures before we started this morning. Again, you can hydromulch them, you can put blankets, you can soft armor them, perimeters, you can cover it with a tarp. It's not too big. Okay? Or you can make it go away for the rain event. If it's small enough, take it away. Unprotected soil stockpile next to an inlet, we don't want that. You know where that's going to end up in the water there. Here it's protected with those gutter eels. Those things weigh 84 pounds apiece. They're not going anywhere. Okay? Here they've got it covered with some plastic, and here they've perimetered it with some silt fence. This is what it looks like after you spray it with hydromulch. Nice big green soil stockpile, very colorful, but again, that's not going anywhere. Covering that stockpile might take a good hydro seeding company 10-15 minutes. Done. If they're really good with it. So again, these are kind of last minute things, but again, we're still not quite up to the rain event. You're still trying to get things ready. Slopes, we're going to talk about all these as slopes. Again, we're going to be hydromulching, doing the same thing. Let's talk about a material that I used and we use in Florida, but it's not common here, that you all should look into until you get approvals. There's a material called anionic polyacrylamide, or PAM. There's several types of PAM. You always want to use the A-grade PAM. A-grade PAM, or A-PAM, has been approved by the US EPA for use in treatment on construction sites. It's in the 2017 Construction Generic Permit. It's also the same material used in drinking water. So it's very, very safe to use. It comes as a concentrated emulsion that you can put in a water tanker. You can use it for dust control. You can use it to spray on a slope. It comes as a granular powder you can use to stabilize slopes and again for dust control, and a gel block that dissolves in water and keeps the water clean. It's been approved by EPA. I've got copies of this EPA document if anybody wants them, and it's in your 2017 CGP. This is a test of a rain simulator by the University of Central Florida. It has the largest rainfall simulator in the world. On the right is an unprotected slope. On the left is a slope with jute and polymer. Anyway, sorry about the noise part there. But what you can see is without polymer, and that was an 8-inch rain event. That's an 8-inch rain event on about a 1.5 to 1 slope, very steep slope, which we have in Florida when we're building our roads next to our coastal areas. 8-inch rain event is now not uncommon. That used to be a 50-year storm event. That's now almost a 5 or 10-year storm event in Florida. So we're seeing more and more. Unprotected slopes wash away. Protected slopes stay in place. The polymer blocks can be used in a passive system in storm drains where they're treating the storm water before it goes off into a retention basin, or they can be designed as a larger treatment system. They basically cause the clay particles to clump together and behave like sand. They drop out by gravity. This is a canal that was muddied up, and this is the canal 24 hours later after one of those polymer blocks was passed over through a pump. All right, what if the rain's about to hit, I've got no extra supplies, I got no money to buy anything, I've got to be creative, right? Y'all know the term MacGyver, we got to MacGyver something. Somebody's got to build something in place of something that normally is a tool that I don't have. So there's a couple of different things you can do. One of those, you can make a diversion from the blue lay flat hose. If you take the blue lay flat hose, which is often used in mud hogs, and tie off one end and pump it up with water, it makes about a 4-inch, very heavy diversion. You can temporarily use that along an edge that you didn't have any way to divert the water or you didn't have any ability to install it. You can protect the slope that way, redirect the water. You do want to weight it down with some sandbags or concrete blocks about every 10 feet. You can go down to the low spot on your perimeter and build you about a 2-foot high earth berm and stabilize that with whatever you've got, plastic, tarps, something. That will help slow the water down so it doesn't blow out your perimeter. You can use parking barricades that might be going in a parking lot, set those up. Again, you're just trying to create a little kind of a check dam holding area. So you can create these with parking blocks, concrete blocks, sandbags, and I've even seen them made out of logs. If you had a bunch of trees near you that had to be taken out. You can add this to your perimeter at the low spot to help get you through the rain event. Now, I wasn't planning on talking about hurricanes, but Marlena wanted me to throw this in here. I am by no means a hurricane expert, but a lot of what we're talking about, again, is just things that are already in a plan that you're going to follow that make sense. So I'm going to review that. So, you should have a written plan. I'm assuming DOT in Hawaii has a written hurricane plan, some version or other. At Disney we had one. It was this massive 700-page document. By the time you read the plan, the hurricane had come and gone. So eventually we had to get it to something that made sense. Again, check the weather. Work with building departments, especially if you're near structures. They want to make sure certain things, certain pieces of equipment, certain cranes are not going to damage an existing building if you're going through an urban area. Secure your job site materials. So again, these are all things that make sense. Plans, nice thing about plans is they usually have things to do 72 hours out, 48 hours out, 24 hours out. They all have like a nice checklist, 24 hours out. We want to make sure all these things are taken care of. Lower cranes, secure these things. Make sure people review this. Make sure people don't go, well, what are we going to do? We're going to follow the plan, right? This isn't new. Somebody else has already thought this up. We're going to secure our construction trailers. We're going to tie down equipment. We're going to get people to assist in making some sandbags, some rock bags if we need those. We're going to plan that our site's going to flood down the low spot. That just makes sense. Water's going to accumulate in the low spot. Hopefully that's not the major part of the road, but that is going to happen. So we're going to need pumps. We're going to need the ability to get that water out of there. If we've got any hazardous chemicals, we're going to make sure those are stored. We're going to secure things. After the storm, we want to let the first responders go through and make sure it's safe. We don't want anybody stepping on power lines or anything dangerous going on with our employees, and make sure that's all going on. So again, just some pictures that go along with that. Ready to pump the water, secure those chemicals, board up our construction sites. Marine storage containers are really good for this, etc. And again, let the first responders do their job. All right. I can show you pictures of our most recent bad hurricane, because you guys had it coming at you. I didn't think I was going to be able to come here. I said, oh my gosh, I finally get to go to Hawaii, and a Category 5 storm is barreling down. Unfortunately, it hit the Big Island and caused damage. Our version of that was Hurricane Michael. Hurricane Michael started out as a tropical depression down here in the Caribbean. Florida's over here. No big deal. We get these all the time. So people kind of don't pay attention to it. A day or two later, they're talking, we think it's going to go through up here, and we think it's going to be a Category 2 or maybe a 3 hurricane. Floridians don't bat an eye. They're like, okay, that's no big deal. Day later, they're going, oh my gosh, this is going to be bad. It's coming in good, 120-mile-an-hour winds. Day after that, they said, this is going to be a Category 4. Category 4 is bad. You need to evacuate. And by the time it actually got there, it was 1 mile an hour short of being a Category 5. 1 mile an hour. Now, I work in a lab. I know categories and how well things work. 1 mile an hour is probably enough of a variance that they really ought to probably go back and look at the damage. They'll probably call that a Category 5 storm. It's definitely a Category 4++. Now, a lot of people didn't get out of the way of the storm. People go, oh, they deserved that. That's not true. This thing went from a Category 1 hurricane to almost a Category 5 hurricane in 72 hours. If you tell people right now that they're living on the beach, they have to evacuate, they're not going to get up and go. They're going to talk about it, think about it, process it. Same with these people. They're hit by hurricanes all the time. They're being told they're going to get hit with almost a Category 5 hurricane, and if you don't leave, you're going to die. And they're like, we've been through this before. They had never been through this, ever. By the time it got upon them, It's too late to leave. Too late to leave. And look how big this storm is. There's a Category 4, 156 miles an hour. At 157, it's a Category 5. Every wind gauge that measured the hurricane flew apart. It disintegrated. It got up to 129 miles an hour and it disintegrated. So they don't really know what the wind was. And look at the rain. This is rain. Look how far the rain's affected here. This is in 24 hours. 10 inches, 8 inches, 3 inches, all the way up the East Coast. Hurricanes cause a massive impact. And you see in the pictures, this could be anywhere, but this is really, really bad. And subsequently the damage. We saw those. Homes destroyed. Trees down. Protected areas lost their roofs. Storm surge wiped everything out. First 1,000, 1,500 feet, gone. More pictures. Solid structures almost destroyed. Trees snapped. Train cars blown off their tracks. An empty train car weighs 60,000 pounds. What kind of force does it take to push it off the train, off the tracks? I don't know. That's pretty strong. Recovery is going to be very slow. The roads are damaged. The utilities infrastructure is gone. But they're making repairs on it. They're working on it. It's going to be a slow recovery. Satellite photos showed almost everything there on the beach area in Mexico Beach wiped out, with the exception of this one home. This one home closest to the beach appeared to have almost no damage. Why? Because the owner built above code. Instead of having 30-foot long pilings, he had 40-foot. Instead of having a roof that could be lifted off, he insisted that he didn't have eaves and everything the wind could get up. He had double-layered windows rated at 140 miles an hour. This is the new building code if you're going to live in coastal Florida. You're going to have to build to this. It cost him an extra 20%. But look what it survived. The guy wrote it out and said he'll never do it again. Right? Even the Air Force Base was ripped to shreds. Ripped to shreds. So, in summary, have a plan. Pay attention to weather reports. Have your materials on site so you can do what you've got to do. Evaluate and adjust the plan. People look at plans and they never change them. After every storm event, you should go back and say what worked, what didn't work. If it worked, do more of it. If it didn't work, figure out why. If it didn't work because it's just the wrong way to go, change that. You have to make changes to these plans. Work the plan. Everybody should be trained in it. They shouldn't go, what are we going to do? We're going to do what we just trained you on and follow it along. None of this is rocket science. These are all things that everybody does. But you have to get out there and do more of it. You have to be involved. That's all I've got. Thank you.